Increasingly, graphical input and output techniques are being combined in order to construct powerful, interactive user interfaces. In the program being demonstrated, the operator is using a number of techniques in order to design a flowchart. The example shows how both hands and various devices can be combined to make use of the operator's full operating potential. Such interfaces are hard to construct, however. In this tape, we will demonstrate two tools developed at the University of Toronto in order to facilitate this task. The first is a runtime support package that handles user interaction. It is a table-driven package that handles all input, event detection, screen updates, and procedure invocation. Even on its own, such a package has several benefits. It frees applications programmers from low-level detail. It facilitates software maintenance by enforcing a common programming methodology for user interfaces. And finally, it facilitates portability of application software, since all interaction is via a standard software package. This next example is a simple chemistry simulation on titration. Adding acid brings a solution to equivalence. Acid is added by pushing the tablet selection button while pointing at the burette. Equivalence is indicated by a color change in the beaker and a sound effect. Let's reconstruct this simple program as a means of illustrating our second main tool, Menulay. Menulay is a program for interactively designing the user interface for menu-driven software. It is a preprocessor whose output is automatically translated into high-level source code. Menulay generated itself, so all interactions used in working through our example are available candidates for our titration experiment. Our first step is to draw the objects which are to appear in the display. Here, a simple sketch editor is being used to draw the burette. Our next step is to design the layout for our display. First, we select and position the graphical elements to be employed. We use our hand-drawn objects, all of which are immediately available through the picture library at the bottom of the screen. We then add the necessary text by positioning the tracking symbol and typing on the keyboard. We then assign colors to the objects. Since we are using a monochrome terminal, colors appear as words. They will, however, be properly displayed when shown on the final device. Next, we will specify the semantics of the experiment. We do this by typing the names of the procedures to be associated with each active object. The procedures must be pre- or post-defined by the applications programmer, or defined on the spot within Menulay. Nearing the end, we will now do the final scaling and positioning of objects. Note that in positioning objects, we can make use of a grid for increased accuracy. Having finished our specification, we now save our work. We are ready to invoke the process that will translate our specification into C code, compile the result, and link it with our runtime support package. In doing so, all options are selectable by the menu. We now exit Menulay and are ready to run our simulation.